Welcome back, children. Now let us try to solve the numerical part of worksheet number 3 from work, energy, power. So here we go. First question from worksheet 3. When a body rolls down an inclined plane, it has. I told you in the previous class that whenever a body is rolling down an inclined plane, it possesses two types of energy by virtue of its position, potential energy, and by virtue of its motion, it possesses kinetic energy. So it has both potential energy as well as kinetic energy, and hence the correct option is option 3, that is both the kinetic and potential energy. So now moving to the next question, second one, the kinetic energy of a body depends on. So what factors the kinetic energy depends on, children? The formula for kinetic energy is half mv square. So the kinetic energy of a body depends on two factors. One is mass of the body and the other is velocity of the body. So the two factors on which it depends is mass of the body and velocity of the body. So where is the correct answer? Only mass, only velocity, mass as well as velocity. Yes, sir. So it depends on both the mass as well as velocity of the body. Third option is true. So moving ahead with the third question, water stored at a height in a dam possesses. Water stored in a overhead dam or a water tank, what energy? By virtue of its position, it possesses potential energy. Therefore, the correct option is it possesses only potential energy because it is stored. Its position is fixed. It's not in motion. So, because of its position, potential energy. So, now moving to the next one, fourth question. Strong wind can turn the blades of a windmill because it possesses that strong wind. What does the strong wind possess? The strong wind which is in motion possesses kinetic energy. So, what is the correct option, children? Option 1. The strong wind having kinetic energy by virtue of its motion and which is able to rotate the blades of the windmill. So, kinetic energy. And fifth one, when the speed of a moving object is doubled, its kinetic energy is. What happens to its kinetic energy? Children, as we know the formula for kinetic energy, what is the formula for kinetic energy? Ke is equals to half mv square. Okay, so let us comparing two things because initially what would be the kinetic energy and finally what happens. Okay, initial kinetic energy let us represent with K1. Then the half is always constant. Initial mass is m1 and initial velocity is v1. So v1 square. Similarly, case 2 is all about because we need to find out the case 2, what happens to its kinetic energy in the second case whenever the velocity is changes. Case 2, K2, so half is constant, mass is m2 and velocity is v2. So K1 is half m1 v1 square and K2 is half m2 v2 square. So what they have given is, you're asked to find the value of K2 where mass, half is of course constant, mass is the previous mass itself, whereas velocity is double the previous velocity. Okay, V2 is 2 times of the initial velocity but mass remains constant, m2 equals to m1. Substituting all the values in the above equation, we have K2 is equals to half of, instead of m2 I can replace it with m1 and instead of v2 I need to replace it with 2v1. So v2 square means 2v1 whole square. So simplifying further, it gives half m1, 2v1 whole square is 2 square v1 square, that is 2 square is 4 v1 square. So keeping all the variables here, bringing only the number 4 forward, this can also be written as 4 times of half m1 v1 square. I just moved 4 forward. Hence, we can conclude that the value of K2 equals to 4 times of, what is half m1 v1 square, children? Half m1 v1 square is equals to initial kinetic energy. Hence, we observed that the kinetic energy becomes 4 times of the previous kinetic energy. So kinetic energy halved, decreases, double or increases by 4 times. What happens to the kinetic energy? It increases by 4 times. So new kinetic energy equals to 4 times of the old kinetic energy. So moving with the next question, sixth one, a flying aeroplane has, what does a flying aeroplane has? Flying aeroplane, because it is in motion, it possesses kinetic energy. It flies at certain height, at certain position from the ground. So it also possesses potential energy. So two types of energies it possesses, potential energy as well as kinetic energy. So where is the correct answer? It has both the kinetic and potential energy. So now moving with the next question, seventh one. If the velocity of an object increases 4 times, what happens to the velocity? Velocity increased to 4 times. So initially V1 is V, then V2 will be 4 times of the V1. Its kinetic energy increases by. So let us check it out, children. So as said earlier, what is the formula for kinetic energy? Kinetic energy equals to half mv1 square. So we have to compare two different conditions. So first one, K1, let us take it as K1 means mass is m1 and velocity is V1. So initial kinetic energy, let us take it as K1 equals to half mv1 square. Similarly, the new kinetic energy, let us represent with K2, which is equals to half m2 v2 square. Half m2 v2 square. But what happens? Velocity of the object increased by 4 times. So what is given means, in the given condition, given V2 is equals to 4 times of V1. Then kinetic. So other values remaining same. So no change in mass and no change in anything. So M2 remains same as M1. So substituting in the above equation, we have K2 is equals to half M2 as same as earlier, and V2 must be replaced with 4V1. V2 square means 4V1 whole square. So this can be written as half M1. 4V1 whole square is 4 square V1 square, that is 16 times of V1 square. So keeping all the terms others, bringing the 16 forward, then it can also be written as 16 times of half m1 v1 square. So what is that? 16 times of half m1 v1 square. But what is half m1 v1 square, children? It is initial kinetic energy. Hence we can conclude that the value of K2 is equals to 16 times of half m1 v1 square is old kinetic energy. Therefore, whenever the velocity of the object increases by 4 times, we observe that kinetic energy increases by 16 times. Hence, the correct option is option 3, that is 16 times. So now, let us move with the next question, children. Eighth one. If a spring is compressed, what happened? If a spring is compressed, the potential energy of the spring. So what happens? Whenever the spring, either it is, if the shape of the spring is changed, whether it is compressed or extended, then what happens? Its energy, more an amount of energy is stored in that. So energy increases. So energy of the spring increases. So whenever, if a spring is compressed, it gains lot of energy. More energy is stored in that. The potential energy of a girl is maximum when she is standing, sitting on the ground, sleeping, or she is sitting on the bed. So, whenever a person is there, so let us consider a girl, okay, so who might be, one case she is standing, other case is sitting on the ground, and So she is standing here, this case. In this case, she is sitting on the ground, she is sleeping on the ground. And one more case is this, sitting on the bed. So bed is there, on the bed again this girl is sitting. So among the 4 cases, which one will be having more potential energy? In order to compare the potential energy, identify its center of mass. Center of mass means the whole weight of the body is supposed to be concentrated at its center. So this is almost at the level of the ground. Here is some H1. Here is again to some extension. Yeah. Ground, no? Yes. Raise it to some height, children, and this is more height. When compared to all the heights, which height is large? Obviously this height. So whenever the girl is in the standing position, then the weight of the body is supposed to be concentrated at a maximum height when compared to all the pictures. Hence, whenever she is in the standing position, then we can say that the potential, as and when the height is increased, the potential energy also increases automatically. Therefore, whenever the girl is in the standing position as compared to the sitting on the ground, sleeping on the ground or sitting on a bed, standing position possess maximum potential energy. Moving to the next one, children. 10th one. A body of mass M possesses a kinetic energy K. Its speed is. Children, we know the formula for kinetic energy Ke or simply K. I'll be writing kinetic energy here. Instead of Ke, I represent it K, half mv square. So kinetic energy K is equals to half mv square. Because they wrote kinetic energy, they represented it with K. So instead of Ke, I wrote it as K only. If K equals to half mv square, then what is the value of V? So here, bringing the 2 here, 2K is equals to mv square. Bringing the m here, 2K by m equals to V square. So if I want to find out the value of V, the value of V will be root over 2K by m. Let me rewrite it once again. So V as V square equals to 2K by m, we can say that the value of V is equals to under root 2K by m. So where is the correct option, children? V is equals to under root 2K by m. Hence, the first option must be true. For 10th question, first option is true. So moving ahead with the next question, that is 11th question. Kinetic energy of a body becomes doubled if its mass and velocity are. So what is the reason? Kinetic energy must be doubled and you are asked to find out whether mass, what happens to the mass and velocity. Let us consider 4 different cases. First one, as we know, the only formula for kinetic energy is K is equals to, or simply K equals to half mv square. Kinetic energy, instead of Ke, I am writing it as K. K equals to half mv square. So first case, let us consider the first case. In the first case, what is given means mass and velocity are doubled. What happens? So K2 is equals to half mv2 square and K1 is equals to half mv1 square. So K2 will be equals to half times of what happened to the mass? Mass velocity doubled. So m2 is 2m1. Doubled. m2 is now 2 times of m1 doubled and velocity also 2 times of v1. So K2 is equals to half of 2m1 into 2 square is 4v1 square. So bringing 4 into 2 into 4, you are getting 8. So 8 times of half, leftover term half, this is m1 and this is v1 square. Here the kinetic energy is 8 times of the old kinetic energy. First case, when the mass and velocity are doubled, we observe that the new kinetic energy is 8 times of the old kinetic energy. So this is not a true statement. So now let us also check it out for the next part, that is case 2. In case 2, what they are doing means mass remaining same, velocity doubled. So case 2, what is the formula for kinetic energy? As usual, half m2 v2 square, or K2 is equals to half of mass remaining same. So the value of new mass m2 is equals to old mass m1. So as it is previous mass. What happened to the velocity? Velocity is doubled. So v2 is equals to 2 times of the old velocity. So instead of v2, I have to replace it with 2 times of new old velocity. So this K2 is found to be half m1, 2 square is 4, v1 square. Keeping all the terms here, bringing the 4, then we'll get K2 is equals to 4 times of half m1 v1 square, or K2 is equals to 4 times of, what is half m v1 square is nothing but K1. Here also we observed that kinetic energy becomes 4 times. So, but they are asking us to when it will get doubled. So, neither the correct answer. You should get it as 2K1. There you are getting 8K1, here you are getting 4K1, but you should get a 2K1. So let us check with the next one, that is third, whether it is true or not. So formula for kinetic energy, half mv square for the second case. Half, what is m2? Mass is doubled. So instead of m2, you have to replace it with 2m1, and velocity remains same. Velocity, old velocity, v2 equals to v1, so v1 square. Therefore, K2 is equals to half 2 times of m1 v1 square. Bringing this 2 earlier, K2 is equals to 2 times of, leftover is half m1 v square. But what is half m1 v square? K1. So, K2 is equals to 2 times of K1. So, very clearly we can say that in the third case, when the mass is doubled and velocity keeping constant, kinetic energy is found to be doubled. So, kinetic energy doubled. This is what we require. Kinetic energy of a body becomes doubled when mass is constant and velocity is doubled. So, no need to check the fourth option. So, we got the answer as third option. So, which one is true, children? Third one is true. If you want to find out, you can also check it out for the fourth option. Okay, if you are interested, you just go with whether it is true or not. Anyhow, we are getting the answer as third one. So next, moving to the 12th question. If a spring is stretched, then the potential energy of the stretched spring, we already discussed it. Whenever the spring is compressed or whenever the spring is stretched, what happens? Its potential, it gains potential energy. Potential energy increases. Therefore, the correct option is potential energy of the stretched spring increases. So, option 2 must be true.